Good morning, children. This is Sanman sir here. In the previous class, we are discussing about similar triangles, right? Triangles. In that, we know that basic proportionality theorem, right? So, what do you mean by basic proportionality theorem? Yes. So, basic proportionality theorem or Bpt theorem or Thales theorem states that in a triangle, if a straight line is drawn parallel to side of a triangle, then it divides into other two sides are proportional, right? So if a straight line is drawn parallel to side of a triangle, then it divides into other two sides proportional, right? Yes. So according to Thales theorem, so we know that PE by EQ is equals to PF by FR. Here EF be the straight line and EF is parallel to QR, right? So by a corollary one, this is a basic proportionality theorem, right? If a straight line, basic proportionality theorem or Thales theorem or Bpt theorem states that if a straight line is drawn parallel to side of a triangle, then it divides into other two sides proportionally. So for example, ABC, in a triangle ABC, DE is parallel to BC. By basic proportionality theorem, if a straight line, here DE be the straight line, so DE which is parallel to BC, then DE divides the other two sides, that is AB and AC, into two ratio, corresponding ratio, right? Proportional, two sides are proportional, right? So if a straight line is drawn parallel to side of a triangle, then it divides into other two sides are proportional. So that is AD by BD and AE by EC. That is the equation, right? So AD by BD which is equals to AE by EC. So that is basic proportionality theorem, right? So by corollary one, see here AD by AB which is equals to AE by EC, right? So AD by AB which is equals to AE by AC, right? This is corollary 1. And then corollary 2, so that is the BD by AB which is equals to AC by AC, right? BD by AB which is equals to AC by AC. That is corollary 2. Okay, so according to the given question, see that question is so in the figure, DE parallel to OQ and DF parallel to OR show that DEF is parallel to QR. So according to figure, so here PQR is a triangle, in that EF is parallel to QR. So we need to show that EF is parallel to QR. So by given data, we get to see DE is parallel to OQ. So right, DE is parallel to OQ and DF is parallel to OR. That is the given data, right? So the triangle can be rewritten as say this is PQR, this is the parental triangle. According to first condition, DE is parallel to OQ. So DE is parallel to OQ. So that is DE is parallel to OQ. Hence in triangle POQ, this is the first triangle. This is the first triangle, right? POQ. In triangle POQ, DE is parallel to OQ. So in that, by basic proportionality theorem, if a straight line is drawn parallel to side of a triangle, then it divides into other two sides are proportional. So that so DE is parallel to OQ. DE by representation only we can say that DE is parallel to OQ. So by applying basic proportionality theorem, we get PE by EQ which is equals to PD by OD, right? PE by EQ which is equals to PD by DO, right? So because we take this first triangle POQ, so by applying DE is parallel to OQ, so by applying Thales theorem we get PE by EQ which is equals to PD by OD. Call it as equation number 1. Then second triangle, that is PQR. So that is the parental triangle. In that, according to second statement, in that according to second given data, that is DF is parallel to OR. So in that second figure, see, this is PQR is a parental triangle. In this, so DF is parallel to OR. DF is parallel to OR. So in triangle PQR, so DF is parallel to OR. So PF by FR, which is equals to PD by DO, right? So by applying basic proportionality theorem, so we know that the Thales theorem, basic proportionality theorem, Bpt theorem states that if a straight line is drawn parallel to side of a triangle, then it divides into other two sides proportionally. So by given basic proportionality theorem, here DF is parallel to OR, so that we can consider this is the second triangle, that is POR. In that second triangle, DF is parallel to OR. DF is parallel to OR. So hence, by applying basic proportionality theorem, we get PF by FR. This is LHS PF by FR, which is equals to PD by OD. Call it as equation number 2. So by comparing equation 1 and equation 2, we get equation 1 and equation 2, we get see that this PD by DO gets cancelled, right? PD by DO and PD by DO gets cancelled. Then remaining here LHS, we have PE by EQ, so that is PE by EQ, and in the second equation we have PF, then remaining PF by FR, right? So on comparing equation number 1 and 2, we get PE by EQ, which is equals to PF by FR, right? PE, so according, yes, hence we get according to basic proportionality theorem states that see, if a straight line is drawn parallel to side of a triangle, then it divides into other two sides are proportional. So that is PE by EQ, which is equals to PF by FR. Hence EF is parallel to QR, right? So hence we get remaining PE by EQ, which is equals to PF by FR. Therefore EF is parallel to QR. EF is parallel to QR by converse of basic proportionality theorem, right? Okay, shall we go for next one? Yes.